go to the people with that need and understand what unique abilities they have rather than looking at their disabilities.
A very good morning, everyone. Welcome you all to the Electronic Engineer Innovation Through Industrial Electronics webinar, which is organized by the IEEE Industrial Electronics Society of Sri Lanka Technological Campus. In the modern era, electronic engineers face a lot of competence while continuing their courses and when applying to their jobs, due to high demand and the special requirements that are created recently for fresh engineers who are new to the electronics. Today's webinar, the Innovation Through Industrial Electronics, will be a huge pillar for undergraduates and fresh graduates when stepping into the industry. Okay, so before moving into the session, there are a couple of announcements to make. The Zoom chat box will be disabled and the mics will be muted throughout the session in order to assure quality and to avoid any disturbances. You can submit your questions to the question form and the answers will be provided in the Q&A session by our facilitator. So without wasting much time, let's move on to the session. To do the honors, I would like to invite our special guest today for today's webinar. He's a lecturer at the School of Computer Science at the University of Sydney. He works in a research field of human-computer interaction, mainly focusing on creating blended interactive systems where technology blends and harmonizes with users and the environment, leveraging on natural affordances of the context. It's none other than Dr. Anusha Vitana.
Thank you very much. Should I start or?
Yes, doctor, you can start.
Right, thank you. Thank you very much for the kind introduction, Magisha, and thank you for inviting me. I hope you can hear me well. It's here. I will start sharing my slides. Before that, I thought I would say this is a great opportunity for me to talk to young engineers like you, and I would like to especially thank everybody who is organizing, and my cousin Dayal and others who are involved. Without taking a lot of time, I will share my slides. Before going to the talk, I have this talk I usually give to, when I'm invited to give a talk, I have a prepared slide deck. So I've slightly modified it to first introduce what kind of research I do and tell you how my research is inspired from, my personal experiences. That's the bit about innovation. And I also prepared another slide deck more focused on engineering and, what engineers should learn and what kind of skills they should have. But I think it is not something new, but it's just my personal opinion. So first part would be about my research. Second part would be like a general presentation. But I would like to keep it as brief and short as possible. So maybe you can ask me some questions and maybe we can continue this as a more interactive and more like a conversational session. Let me try to share my slides. I hope you can see my slides. Can you see my slides?
Yes, sir, we can.
All right, good. Okay. So I want to start sharing my story, how I went into research and how my personal experiences have informed or inspired my research to begin with, right? Um, my research is in human-computer interaction. It's basically about, like, the general research area is about how we can create technologies to help people, or how to create better technologies that can be that can create better user experience. People can use it easily, and rather than creating technologies that are left out in history, like nobody uses anymore. But I am working in a very specific area, and I will explain a little bit about my research to begin with. I think my from my the introduction Vagisha gave, it's very clear. But I'm currently a lecturer and an ARC DECRA fellow here in the School of Computer Science. As you can see, I'm not in electronics anymore. I work in computer science, but you can see in my presentation later that I still do a lot of electronics. And I used to work in Germany and Singapore, and I did my postgraduate studies in Japan. Before that, I was a student in Sri Lanka, like you. Um, I was at the University of Moratuwa doing electronics engineering. I want to start, I want to share a story when I was a young student, 7 years old, studying in a countryside primary school. It's an important story that kind of informed my research. Um, it was the Earth Day in Sri Lanka, and there was an art competition. So you have to make a drawing um, about environment, how to protect environment, how to raise awareness. And my drawing or painting was basically the map of Sri Lanka. This is not the actual drawing. I don't have it. Something like this. The shape of the country, surrounded by, of course, beautiful blue ocean, sea, and then there are a bunch of trees in the middle of the country, showing that we want to um, make our country full of trees and lush, right? I actually won the competition for this drawing. It's a small school, so it's not a big deal, but it was a big deal for me. But my teacher specifically, she said, this shows a lot of artistic potential, because there's a lot of underlying things in this particular drawing, because um, I've shown the environmental disaster sense, because I colored all my trees in red, like trees are bleeding. Now, I tell you, I didn't think about it that way. But I thought maybe I must have some sort of talent, hidden talent inside me to draw this, right? And I accepted the award, and I was very happy. And later on, sometime later, when I joined University of Moratuwa, they had a medical checkup, and they showed me this, and they asked me, what is the number written on this, uh, in these dots? And I couldn't see a number, and I still can't. I'm still struggling, but I can see it a little bit. I think there are a lot of people in the audience, and maybe 20% of you wouldn't be able to see what is the number written here. And people who know, I didn't know at the time, people who know that this is a test for color blindness. So after doing this test, I realized I'm colorblind, and I'm red and green colorblind. So it's in the severe range of the spectrum. So it's very difficult for me to distinguish between these two colors when they are blended. And going back to the artwork that I won the award for, now you can see like why I didn't mean to put that subtext in the art that trees are bleeding, because I thought I am coloring these trees in green because I'm colorblind. I mistook red for green, but it led me to win an award, right? Now, whenever I share this story, the first question people ask me is, do you see things in black and white? No, I see almost all the colors. I even see red and green, but when they are mixed together side by side and in different shades, I cannot really distinguish them. This is the way that physiologically how your eye is constructed. There are cones and cylinders, and the balance is not as same as most people, but there are a lot of people with color blindness. And it is actually quite frustrating to explain how color blindness works, because if you haven't experienced it, you don't know what it is. And it is very difficult and subtle thing to explain. So when you think about it, if it is so difficult for me to explain something simple as color blindness, and I don't consider myself disabled because of this, but how difficult it is for someone with real disabilities, like somebody who cannot move, who cannot speak, or who cannot hear, or who cannot see, how difficult it is to understand and explain and express themselves. Because the disabilities are highly personal, and unique, and different people experience it in different ways, and it is changing often, right? I mean, most of the time it is for the worst. Your disabilities are getting severe and severe. Sometimes it gets better, and that is what we hope for, but it is a challenge to explain, for a disabled person to explain what they need. And as an engineer, from my personal experience, I want to develop technologies that help people with disabilities, but it is important to understand them, understand their needs before actually developing technologies. Most of the technologies you see developed for people with disabilities um, um, are left abandoned because nobody really want to use them. They are burdened to use. So this is the root of my, pathway to research, and research is always innovation. So this is why I wanted to share this experience with you. So I work in, well, first of all, how the current system works as an engineer when you go into industry, what I call a factory model. This is how we develop things, right? We have a big assembly pipeline, and we make things and we send it to the users, and we don't care what they need, or we care about general population, but at the end of the day it is designed for everybody, and everybody has to learn. So when someone with a disability get something made in a pipeline like this, what we are saying is basically, we don't care about your personal needs, but we made this, and here's how to use it, and figure out how to use it. I don't think this is a sustainable system. So that's why in my research, I want to look at the user and what kind of needs users have, like what kind of functional needs, what they want out of a system that we design or develop, or how should it look and feel. This is very important. A lot of people ignore it, but look and feel, the experience is very important. And what kind of data we should collect is very important, because it's it's with the internet, everything is, you have to be very careful with data, because there are a lot of issues with privacy and security and other things. So you don't want vulnerable people to be exposed to that sort of stuff. So in my research, I look at how to develop highly personalized solutions. We rather than developing things for everybody, we want to develop things for the individual, which I call design for me, like highly personalized things. How we go about it, I mean, this is very easy to say, but from an engineer's perspective, if you want to design one by one, it's going to be, first of all, it's going to be really expensive. And also it is going to be very slow, so you cannot really cater for the demand. So engineering perspective, this is very difficult. So this is a problem, right? This is where the innovation is important. When there are bigger problems, you have to come up with bigger ideas. You have to think out of the box. So my way of doing it is combining personalized design and computational fabrication. Now I'm going to explain this simply. It sounds very complicated, but it is not that complicated. So for personalized designs, I create technologies, so user interfaces, software that help people to design their own thing. Like if it is a sensor, they can specify, what is the shape and the size and the color, and all the technical jargon we can program, we can automate to automatically develop. This is a tool that we recently published that help people to design their own sensor. And once it is designed, we have to make it. To that end, I use computational fabrication. Computational fabrication is anything that helps to translate something that is digital into a physical domain. And it is basically more or less automated. And you would see, if you have had any training with modern CNC machines and tooling systems, they are all kind of follow computational fabrication. So in this case, in this particular sensor, what we did was we hacked a desktop printer. This is a normal printer, and we changed the ink to print conductive inks. So you can design it on your desktop and you can print it then and there. Once you print it, it works exactly like a normal sensor. So this is multi-touch sensor we printed. So this has comparable resolution to your, if you are using a smartphone like iPhone or something else, it has pretty much comparable resolution. But the cool thing is, because it is personalized, now you don't have to go into that box shaped iPhone, whatever the sensor. You can do different stuff. Like you can create a sensor that works in a, basically convert your toy to an interactive device, or make a card because you can print it, right? But more importantly, this is where this is going to be very helpful when it comes to wearable devices, right? Because our body is so different. And I might feel that I want something on my forearm, like a smartwatch to wear as an assistive device. But someone else with disabilities, they might not be able to reach their forearm. They might want something on their palm or ear. So they can specify what the device they want and what it should look like, and we can print it and we can make it work. And these are all actual devices, working devices that we printed with this desktop setup. So this is very important when it comes to people with disabilities. But also it is not limited to this sort of printing, but we can also embroider things, right? Like modern embroidery machines are designed to work with computers. So we can embroider things automatically using conductive yarns and conductive threads. And then you can create like this interactive sleeve. So the goal here is how to create technology disappear. So this is my personal research area, how to create technology completely disappear. And you don't want to, if you look at somebody who cannot move, if you look at these modern wheelchairs, they are so big and loud and very, very intrusive. Everybody can see immediately, there's something different. We don't want that. In future, I think the technology should completely disappear and you wouldn't be able to even notice that someone has a disability. A good example is like modern hearing aids. I have a cousin who has a hearing disability, and I remember like he hated wearing hearing aids because they look big. Everybody can notice there's a problem. But now the modern hearing aids are embedded inside your skin, and you wouldn't be able to even see the person has a hearing disability. And that's where we should lead. So one of the recent projects I did is in electronic skin or electronic tattoos. This is a tattoo we developed that can provide tactile feedback. Tactile feedback is something like, when your phone vibrates, that's a tactile feedback, the feedback that you sense through your skin. So this particular tattoo can communicate with nerve fibers inside your skin and kind of send electrical pulses. So the brain interprets it as a vibration. Now, there is no real vibration in this particular tattoo. It's so thin, there is no way that we can integrate any mechanical stuff, but it is just a bunch of electrodes and electrically stimulating the skin. So the main breakthrough here is it is so thin, right? You cannot even feel it on your skin. So it's the first ever feel through tactile interface, and it's so thin, it's like 35 microns, which is like half the thickness of average human hair. and and it is so conformal, like it even like go into the tiny fingerprint wrinkles on your finger pad. So that this the other advantage of this sort of device is it is high taxel density, meaning taxel is like pixels in your phone, but like how many vibratory elements are there. So taxel density is important if you convey information, useful information. Think about something like braille, right? So this sort of device can send braille patterns to the skin, and there's you don't have to wear anything bulky. Nobody will even notice this on your skin, and you cannot feel it yourself. That is also very important. And because this is also printed, so because it is printed, we can design it for different areas of the body depending on what the users want to wear, right? Here is a quick video we created to showcase this, so we can use it for different applications. Now, this is particularly not only for people who cannot see. We can also use it for like virtual reality. You can see things in virtual reality, but you cannot feel. With this kind of devices, you can actually feel things in virtual reality. So what is in future? I want to kind of summarize what we are doing at the moment and maybe move on to the next part. So we are developing that kind of like tactile interfaces for people with disabilities. Like I use Google Maps all the time. I'm not sure how often you use it in Sri Lanka, but I use it all the time here in Sydney because I lived in many countries. It's very difficult to remember all the roads. I always use it. And this is very difficult if you cannot see, right? We don't appreciate how easy we have it. So we are developing some tactile technologies for people with visual impairments, similar to Tacto, to navigate visual information better. Also, we are developing new kind of 3D printed sensors. So it's not only about desktop inkjet printing, but also 3D printing. So 3D printing can create interesting mechanical structures that can do sensing, which is beyond what you can do with normal sensors. For example, in this particular project, what we are doing is we are going to create a bracelet that is actually we've already created it, a bracelet that can be worn on the wrist, but it can detect excuse me, detect subtle finger movements, very tiny finger movements. So some people with certain disabilities cannot move their fingers all the way. So, and also they don't want to wear heavy gloves or anything to sense this. But if you can sense finger movements through the wrist, that's a big advantage, right? So you can wear something like a smartwatch and have these sensors embedded in the strap of the watch, and through the vibrations in the carpal tunnel, because all the fingers are controlled through tendons running through the carpal tunnel, we can sense that and we can detect it. This is where the things like machine learning is very important. I will talk about it a little bit further later. So this is my area of research, how to weave technology into our lifestyles, how to create technologies that disappear into our body and things that we wear basically. So to do that, we use advanced fabrication technologies like 3D printing, laser cutting, inkjet printing, as I showed you. So we have like a lab set up here in the University of Sydney that we do a lot of these activities like laser cutting, 3D printing. So even though I am working in human computer interaction, I do a lot of computational stuff. At the end of the day, I'm still pretty much an electronic engineer. You can see all these things. At the end of the day, we need some electronics. But the reality is that things are moving more towards computing than anything else at the moment. Everything else is getting easier. So that's a bit about my research. Now I'm gonna stop sharing and I'm gonna switch to the other presentation about more focused on what you wanted to learn today. But if you have any questions about this, I don't know what is the setup is. You can ask it later or you can ask now. It's fine. So let me just switch to the other presentation. Right. All right, I hope you can see it. So because this session is about engineering and how to build your career, right? So I thought that I would talk a little bit about my career as an engineer. Some tips, mostly personal experiences and my opinion. So I'm not sure how valid they are, but I thought maybe I will just prepare something for the sake of it. So first of all, you should ask, considering I'm a lecturer and I spend a lot of time in research, am I still an engineer? So this is something you should decide. Should you follow my advice or should you get a professional engineer to talk about what engineering is all about? My career as an engineer was very brief because I worked at Dialog for about a year before I went on to do my postgraduate studies. Since then, I've been working in research, but there is a strong engineering component in all the projects I do. So as a student, as a researcher, and now as an academic, I use a lot of engineering in my work. So maybe some of it is relevant. So how to become a good engineer? I thought this is a good question to ask. And I thought the first thing you should know as a good engineer is you should know how to Google. So first thing I did was I Googled it, what are the important things that good engineers should do and must have. And I bump into this one in newengineer.com. And I thought like, this is a fantastic summary. I don't have to prepare anything. I will just talk about this stuff and that's it, because that's exactly what it is. So first of all, you have to be a team player. Engineering is a team job, not individual, and you have to learn always. You have to be creative, of course. Learning is different from creativity, right? Then you have to be a problem solver. Now creativity and problem solving goes together. You need the learning to do that, and you have to have analytical abilities. Analytical abilities means when presented with a problem, you should be able to figure out what are the different things within this problem, how to compartmentalize, how to solve it. And you need to have good communication skills, because you have to communicate the problems, you have to communicate the solutions. You cannot build everything by yourself. You have to have logical thinking, attention to detail. Logical thinking is very important. It goes with analytical abilities and problem solving. Attention to detail is also very important, because you have to, engineering is always about details. I don't know why mathematical ability is at number 9, but as an engineer, I found like mathematics is at the core. You have to really look at theoretical stuff. I've had many situations where certain decisions you can just do with mathematics. For example, what is the best way to go about a problem? You can just write the equations and figure out, okay, it's going to be this much or that much, or you need this sort of a sensor versus a different sort of sensor. This is very important, right? And leadership. You will find, especially in Sri Lanka, if you work in Sri Lanka as an engineer, you will be mostly working as in a managerial level, and you would be advising others, and so you need to have that leadership skills and other soft skills in your career other than technical stuff, right? This is very important. A lot of engineers forget that. A lot of engineers don't care about, things like human resources or management and all that stuff. When I was a student, these were mandatory subjects I had to take, and I hated it. But now I realize how important they are. So you have to have those skills. But this is something you can probably you already know. Probably you already Google um, it. So I thought maybe I will share some things from my experiences. Most of them are kind of captured here, but maybe give some examples quickly. First of all, I think you should do what you love to do. You shouldn't do when you there is in I don't know, maybe in Sri Lanka at least there is a notion that, oh, you want to become an engineer. Don't become an engineer just because your parents tell you to, for the fame of it or whatever. I mean, it's not that cool to become an engineer I think in Sri Lanka. Maybe if you do it, you should go for medicine or become a lawyer. But if you are an engineer, and if you want to do engineering, do something you like to do, because it is a big area, and within that, different you have different choices. You can choose from which area you want to go. Maybe you are good at programming and you enjoy programming. Maybe you are good at building things, like maybe you are good at electronics. I suppose everybody here are good at electronics, that's why they are here. But choose something you want to do, you really enjoy doing. Otherwise, you cannot be good at it. Only reason one will be good at something is because they really enjoy doing it. They like learning about it. They like doing the same thing again and again and failing, and but still fighting, right? This is very important. Second thing is the analytical ability and creativity. I just put these two together because I thought these go in hand in engineering, because you have to have analytical ability to figure out a problem, and you should have creativity. In my experience, well, my opinion is engineers are artists who create useful things. Now, art is, if you look at artists are highly creative. They come up with really cool things, but they don't care about if it is useful, right? They don't care about utility. Art is there for art's sake. Nobody really, you enjoy it, but there's no utility to it, right? You cannot there are artwork that is sold for millions of dollars, pieces of music sold for earning millions, right? And movies earning a lot of money, but it doesn't have a real use other than the entertainment itself. Most of the art kind of it's there for itself. There's this famous book from Don Norman about how utility and art is, like the design and art is different, how it is similar and different. So I just wanted to show this image of a pot. Now here you can put your analytical abilities to use. Now, when you see this pot, do you see any problem in this pot, right? Does your engineering instinct play into this immediately, and like you see, okay, there's a problem. This is, by the way, a piece of art, so it doesn't meant to be really useful. It is useful, it works as it is, but there is a problem, right? If you are an engineer, when you look at this, you immediately notice what is the problem. That is the analytical ability. Um, because your mics are muted, I'll explain. So you have the handle here, and you have the, I don't know what is this called, but whatever, if you want to pour your tea out of this pot, it's not going to work, right? That's the artistic bit about it. It's kind of makes you think. But as an engineer, we immediately go into that analytical mindset and decide, okay, this is not useful. So in engineering, we create things, we use creativity, but we think about usability, how it is going to be useful, right? So this is very important. And the next bit is, I think you have to become really good at what you do if you want to be successful. Always have this T-shaped skills, right? Most managers have this kind of like a wider range of different things that they know. But as an engineer, if you still want to be an engineer, not just a manager, you should have this T-shaped skill set where you know most of the stuff in engineering. As an electronic engineer, you know about digital stuff, analog stuff, how different comparators work or something, how filters work. But at the same time, you have a specific area that you're really, really an expert of. So that area you really know deep into it. You know your stuff, right? So that's very important. Think about your T-shaped skill set. Like, most things, but one area very well. That's where your engineering identity is, right? That's very important. And also another thing, whenever I talk about these, like the breadth of experience and depth of experience, people feel, some especially starting engineers feel like they have to know everything. If you don't know something, always admit it. Just say, oh, sorry, I don't know about it, but I can learn, rather than saying I know and you don't know, and they realize that you don't know, that and you're lying. That's not a good thing. So that's from my personal experience. I would always admit that, okay, sorry, I don't know about it, but I can learn, right? And so following to that, you have to be always curious and open to learning. I think there was a little bit in the flyer about what are the important things you should learn. I wouldn't say like this particular thing is important, but you should be curious and you should learn. You should always be on top of things. When there is something new come in your area, you should be aware of that. At least you should know what is the basic principles. And if somebody asks, you should know this, at least that exists, and it's something that you should learn. I think the best way is to subscribe to tech magazines. They are very good at figuring what is happening around the world and reporting them very brief, in more how to say, more digestible ways than most research papers, so that that this is happening. There are a lot of online magazines like Wired and this and that, and I used to subscribe to their newsletters. It's very important. But also being in groups like this, I mean, you are already on top of it, I think, because you are here and you are already part of this group and you share your knowledge. That's very important. And use new sources of information. You would be surprised how much you can learn from social media like Twitter and YouTube. I'm not a big Facebook fan, but YouTube is really cool. These are three channels I regularly watch. Veritasium, Khan Academy, and Three Blue and One Brown. So the Veritasium is more scientific innovation stuff. Khan Academy is about learning different things. If you want to learn, I don't know, something quickly, probably Khan Academy is the best place to start. Three Blue, One Brown is more about mathematics, but it is so beautiful what you can learn from these places. And it's YouTube, so you can watch it, and it's they do it in a very fun and enjoyable way as well. So I watched a lot of their videos. I would highly recommend you looking into this stuff. And furthermore, you have to also choose what you want to learn, because we don't have a lot of time. So you should think about what areas are important as an engineer. I would say, learn how to code. This is essential in any engineering area or any science, any actually, if you even go to financial industry or something, completely different, you still need to code now. It's essential. Even like more modern arts like electronic arts and computer art, you have to code. And it is ubiquitous. And as electronic engineers, you would be surprised how much programming is necessary in any electronic system. I mean, I'm sure you know about things like Arduino, right? If you look at it, there's minimum amount of electronics you have to do, but you have to do a lot of programming, right? And even at higher ends like FPGAs, at the end of the day, everything is in programming, right? You do either VHDL or Verilog or whatever the language you use. You just go and set basically all the configurations is programming. So you really need to be on top of that. And also decide. This is a video I found in YouTube. I thought it is pretty cool. Like, look at how coding has evolved over the time, even last 5-6 years. The languages that are popular is changing rapidly, right? If you can see, JavaScript is going over the roof. I think JavaScript is one of the most important languages if you want to learn, because you are very time poor. You should figure out what languages to learn. And if you don't know, if you haven't really paid attention to programming, I would say go for something quite well used very widely, because then you have more resources to learn. If you run into a problem, that means more people are using it, means there are more resources. The probability of someone else's experiencing that problem is very high. That means you can get help very fast. So I would recommend either go for something like JavaScript or Python. Let me just move this to the very end. Let me see. Yeah. So you can see now it's basically JavaScript and Python is at the top. I would highly recommend you to, if you don't use them, just start, thinking about learning one of these languages is going to be essential when you go into workforce, right? How do I go to the next one? Yeah. So continue doing, you always be alerted about what is happening in the world. And the other thing I would recommend that you should learn is machine learning. And I talked about this a little bit earlier. As electronics engineers, we are not very much attuned with what is happening in machine learning world, but this is very, very important. And why we need it? If you look at classical systems, like this is what we learned. I mean, this is a very simple example of what we learned. If you have a system and you have a switch, and then you have like a little bit of overshoot and damping, but at the end of the day, if you want to see if the switch is on or off, you can put a simple threshold somewhere here around 90% of the pulse, and then you can basically measure it in any electronic system, like a simple comparator or something. You just, even in a analog to digital converted system, it's just going to be simple if else statement. But in the modern world, it's not the case, because our sensors we use are getting extremely complicated. So the signals kind of looks like this. This is a project we did to detect heart rate in real world activities like stationary, walking, and running. These are signals from two different locations. Depending on the location, you can see some, like in the right hand side, you can clearly see the heartbeat. Whereas in the left-hand side, you cannot even make sense of. This is basically overlaying multiple heartbeats all together as a density map. You can see you can barely make sense of what is here, right? So another example is the project I showed you, like this wearable bracelet that we 3D printed. These are 3 signals from these sensors. You can see they are very slightly different, but even our human eye cannot make sense of what is happening. So you cannot put a simple threshold and say, hey, this is what is happening. This is a very complex problem that is hard to solve by our classical understanding. This is where the machine learning come in. So a machine learning system will learn how these signals are different, or what is the peak, or the where the peak is happening in this complicated signal very easily, right? Because they are very complicated systems. So this is a simple neural network or deep learned neural network. What is happening here is, at the end of the day, very simple. It's very easy to explain. Basically, you put all the crazy signals that you see here, and you say, given a signal, this is the output is, we say, this. And there's this method called backpropagation, and all these nodes has certain values, and this can be mapped into a very complex equation, very complex one. It's, I mean, it is so complex that it is actually difficult to even write. But through, if you have a lot of data, you can train automatically this system to kind of classify what is happening in that signal and figure out where is the heartbeat is, or what kind of movements that fingers make in that second sensor I showed you. But this is a very complex process, and it is very difficult to explain the theoretical aspect, but to use them, this is what is important. Okay, for as engineers, if you're not in machine learning research, you don't really have to go into all the nuts and bolts of it, but you can use it. There are so many open source tools. For classical learning stuff, you can use scikit-learn. If you are a programmer, this is the best tool. You just use it, and simple tool, you can input the data and figure out, what is the you can input the data and train a simple system very easily. You only have maybe less than 50 lines of code, and you can get a real-time system working. And if you are not a programmer, there are tools like Weka, which captures so many different types of machine learning algorithms, and it is a GUI tool, so you can use the Explorer section. I would recommend you to use this, because there are a lot of freely available data sources. You can trial it out, and you import the data, and it will classify, and whatever the data you give, you can build your own classification, machine learning based classification system. Now, if you have a lot of data and it is too complicated, you can go to something like TensorFlow, where you use deep learning. So I think these are like some of the tools that you should be exposed to, you should try out, you should learn. I'm not sure if it is already taught in your curriculum, but I thought this is a very important area. And also, I want to add a little bit about my own research. Like, you should think about what the users and clients need. So this is a funny cartoon that shows how different people see different things. Sorry. So when this is how a customer would explain a swing should look like. This is how the project leader understand it. You can see it's not going to work. How the analysts design it, so you design this one and you go to this one, but how different actors actually design things and understand it. This is where the communication bit is very important. And also you should pay attention to your user and client and really understand the problem. This is where my research is partially in human computer interaction, how to understand the requirements. A lot of engineers, we think that we know what is best for the user. Don't ever assume you know what is best for the user. It should be you should follow through a process and learn what user need, and do many alternative designs before you implement something. And learn how to manage your time. This is absolutely important. I see this as a weakness in myself. So you are going to be a manager, and it is important to manage your time. Learn to use things like calendars, to-dos, and all the tools available. And also don't promise things you cannot deliver. Never say like, oh, I'll do it in 2 days and then not deliver it. That's very bad. You should always do a proper assessment before you promise anything. And you use the right tool for right job, right? So for example, don't set up a Wi-Fi system where you can resolve the problem with Bluetooth, right? Always go for the cheaper, more energy efficient solution. Think about something before, don't overkill the problem. You just need to do a proper analysis. And finally, most importantly, be a good teammate. Be good for people around you, people you work with, create good networks. And finally, enjoy your work. Yeah, that's the most important thing. At the end of the day, you should enjoy your work. Sorry if it ran a little bit longer than I expected, but I actually prepared the slide deck this morning. I'll stop here and I'll answer any questions you have.
Thank you very much, sir. So it's time to move on to the Q&A session. So I kindly invite all of you, if you have any questions regarding the session, or if you have anything to clarify, make sure to drop your question by clicking the link in the chat box. So we have received some questions. Let's take a look at the first question. So the first question is, what are the other platforms to develop advanced robots except Arduino, Raspberry Pi, Node MCU, etc.? What are the other platforms?
What did you mention? So Arduino, Raspberry Pi, and
Node MCU.
Oh yeah.
Node
So
MCU.
I mean, there are. This is something. There are so many things. I cannot even begin to say. There are so many companies coming up with different solutions, and they are based on different needs, right? Like imagine if you want to create something that is networked, then you have to think about what kind of network you want, and depending on that, you can find a different solution. We use NRF based technologies mostly. Like there's something called NRF Feather that is developed based on NRF Nordic microchips, which has Bluetooth low energy inbuilt. So we do a lot of low power sensing things. We use that platform for that, right? And also there's a Intel platform that work in a different area. I'm not sure if I can answer that question fully, but I would say this is where the Google is going to be a better friend. I would say for robotics application, there are many different platforms with pluggable architecture and use robotic OS. I would highly recommend to look into that. But I'm not sure I can fully answer the question as like a list of things you can use, but definitely there are so many different platforms available. That depends on the application. If you want to control models and it is a closed loop system, you don't need communication, that will be a different system. If you need to control something that is 50 meters or indoor, that will be a different system, that maybe you have to use a networking system like Zigbee, right? If you want to control a robot that is going into farming and goes few kilometers away from your control station, then you might have to look at something like LoRa, which is new generation IoT system, Internet of Things networking system. So there are LoRa devices that can communicate very slow, but can send messages over a few kilometers, I think even up to 6-7 kilometers. I don't remember the exact range, and they are very low power. So
thank you, sir. So the next question we have received is, will there be any changes in the future in electronics industry after the COVID-19 pandemic?
I think there are changes in every industry. not only electronics. Definitely, there are a lot of changes. If you look at it is from the conception to end, like even the manufacturing processes are changing, right? Um, the automation is going to be a key part. Working from home is going to be a huge thing that engineers and others would have to work on. I mean, this Zoom platform, you can see how ubiquitous it is now. Last year or 2 years ago, people barely knew about what is this about. People rarely use these applications for real work, but now everything is changing and everything is going online and people need to work from home. Now imagine when you are working from home, how to create effective meetings. We are now using just audio and video, but in future we would have to do other mediums, right? Imagine how you imagine an architecture firm, right? They build models and how that changes. So this is where the 3D printing and other stuff is going to be very important as well. So the whole area is going to be whole e- not only engineering and electronics, everything is going to be changed, but it is very difficult to anticipate. But from my personal experiences, I think um, the communication, the way we work is going to be transformed. Right now in Australia, there are a lot of people who used to maybe work 1 day from home, now change to they just come to work 1 day a week and they work from home 4 days a week, right? This means transformation. This means there are a lot of things need to be innovated. For example, imagine how we connect, like internet connectivity is going to be changed even in countries like Sri Lanka. I think people will understand that better. And also access and how think about simple things like money. Like in Australia now, barely anybody use money anymore. They all have this tap card, and that's what you use. Like it's touchless, paying everything without touching anything, right? Because money can be a factor in spreading these diseases. So I think it is definitely changing, but it is very difficult to predict which way it is going to go. That's a good question.
Okay, sir. So the next question is, how much far would the GPA go or take you in engineering?
As an engineer, I don't think it matters. It is important for you to get to get through the interview, right? If you have a good GPA, that is indicative of you are doing, you are good at learning things and solving problems at exams. But I realized that once you go into the workforce, that's another starting point. So the think of it this way: your A-level results are important for you to get to where you are now, right? But your A-level results doesn't really matter once you graduate, because then it's just another certificate. You have something higher than that. When you go to the workplace, you will create your own interesting credentials among your colleagues. That's why being a team player is also important. But people will understand, your manager will understand your abilities independently. But at the end of the day, GPA is something everybody would look at. So don't undermine the importance. It's very important to get into things. Anywhere, like let's say if you want to apply for higher education, everybody will look at GPA. So it's very important, but it becomes irrelevant once you get in and once you start working. They wouldn't really, people will not remember your GPA. People will remember what kind of work you did, what kind of problems you solved at work.
Okay, thank you, sir. So the next question is there a way we can enter the field while being an undergraduate student?
Yeah, of course. You can be an intern. You can be, you can, this is actually quite interesting. Like if you look at how students work in countries like Australia, they are working while they are students, right? They find jobs while they are students, but we don't do it. I think that is a mistake. We should try to, you or in first year, second year, after your first year, second year studies, you have certain abilities and skills already you can contribute. That is the first way to do it, right? You can look for internship opportunities. You can connect with this kind of through this sort of networks, and companies are always willing to hire people like you. They might not pay as much as an engineer, but it's a good experience, right? The second way is to do your own independent work. You can go to freelancer or some network like that, and you can find jobs. People always post, like for example, there are plenty of design jobs. Like somebody wants to design, get a circuit designed or a PCB designed, and they would post it online and say, hey, I can pay this much if you want to, if somebody can design this. It might take few days, but you learn something and you also earn a little bit of money, and you can put it in your experience. So I think that is a good instinct to have. Always try to um, find this some work, get into the field, but also you can do your independent work, right? I have friends, and I myself build things for just for fun. That's very, very, very useful. I mean, you can go to GitHub.io and you can create your website, and you can post all your work online, and you can build your own thing. So I think there are three ways. Those are the three ways I can see you can get into the field very early on, and I think you should.
Thank you, sir. So the last question for today's session is, how competitive is the electronic engineering field, and how would competition be in the future?
It's okay. That's competition in terms of the job market. I think it is very competitive, but it is not as competitive as computing, for example, right? Because there are so many people who can program and who can, write code. You can learn it from home. I think electronics is a little bit more of an skill-driven field. So it's not as easy to learn. You have to have real life experience building things. So it is a little bit more specialized. But at the end of the day, you have a lot of electronics engineers and electrical engineers as well. I think it is competitive, but there is a lot of need as well. And there are a lot of sub areas you can choose from. It is competitive. It is going to be competitive, but it is not one of those areas you have a lot of talent. So in a sense, you probably are in more demand given some other fields. So it's a good place to be in. I like electronics. I like building things. So definitely competitive, high in demand, but you have that unique thing where you have a physical experience as opposed to like coding. So I think it is a I don't know, for me, I still believe that electronics engineering people, hardware people are in more demand, so you have more bargaining power. It's a good um, it's one of the better areas of engineering to be. But said that, I should say it is also becoming highly competitive because people are understanding how important it is to build things.
Thank you, sir. So that brings us to the end of our Q&A session, and eventually moving on to the conclusion of today's session, I would like to invite the chairman of the organizing committee of this webinar, Dilshan Vitana, to deliver the vote of thanks.
Okay, Vagisha, am I audible?
Yes, I am. You are good.
Yeah, thank you. Good morning, everyone. First and foremost, I would like to thank our spokesperson, Dr. Anusha Vitana, for kindly accepting our invitation to come and enlighten the future of engineering technology of our country, even his busy schedule. Thank you so much, sir, for sharing your knowledge and experiences with us. And it was very interesting and valuable session. Next, I would also like to thank all our project advisors for constantly being there with us and guiding us to success this event. I would also like to thank all of you who are present representing various universities, schools, and the students of SLTC for participating today's webinar, and we hope that your minds were enlightened to reach for your goals, career, and dreams with confidence. Last and not least, I would also like to thank my fellow committee members for all the work that you put out in order for this webinar to meet a successful, satisfactory ending. So again, wish you all a very good morning and stay safe. Thank you so much and have a nice day. Thank you, Vagisha.
Thank you, Darshanaya. So that brings us to the end of our Innovation Through Industrial Electronics webinar. And we hope you got the best out of this. So we hope to see you all with many more sessions like this in the future. Until then, stay safe and have a good day. Thank you.